Hello, everybody. Um, Today we're gonna go back to making a game engine. Happy New Year's. First New Year stream. Let's go. Um, let's see here. Last time we left off, we created an Vulkan instance and debugging, so that's good. Um, let's see here. We do have loggers, and yeah, go ahead and switch our screen here. So, like I said last time, we created our Vulkan instance, and we also created our debugging information. Um, so that's good. Now, what we need to do now, I believe, hold on, Vulkan tutorials, is to create our surface. Yada, yada, yada. Destroy instance, destroy message. All right. So now we need to set up our physical devices and queue. Anyway, so new file, Vulkan device. E pragma once include vulkan.vpp namespace Control C, Control V. Class Vulkan device. There we go. Um, we got Vulkan device and physical device, and that's pretty much all we need to get that started, or to get that abstracted. Let me get the chat up. All right. So we need to pick our physical devices. Um, our physical device gonna take in our instance. So Vulkan physical device. We need a constructor. Um, a Vulkan physical device, destructor, Vulkan physical device. We want a constant bulk vk instance, reference to instance. And that's it. Okay. All right, so a constant vk instance reference to our instance variable. We do this through the initializer list. And that's all good. Vulkan physical device. Vulkan device. So our end goal is a Vulkan device. That's pretty much it. To do that, we need to get a list of our physical devices first. Go. What's going on here? Um, so it's gonna be weird how I'm gonna probably gonna do this, but with the physical device, it's gonna also hold our cues, I believe. So VK physical device, VK physical device. Inline const VK physical device reference get physical. That's just our getter method for our physical device and such. Um, Something that we need to do is create an instance for all devices. And what I can do here is create a static void in it. We can enumerate the devices and create a list. Of Vulkan physical devices. And that's pretty much what I'm gonna do is create an instance here. Um, reference. Oh, right. So we need to enumerate our physical devices. To do this, HTTP test. Let's see what I need to do here. Include HTTP. Feedback callback. Okay, devices. So we do have an auto device. And then okay, this gets interesting. We can hmm. All right, what I can do. I'm going all over the place here. Let's see. Instead of just having a physical device class, it looks like we can do Vulkan device Okay, instance. Physical device, PK device. Alright, here we go. So, Vulkan physical device, device 0. Um, we can have this. Vulkan device. Const PK instance reference instance and const PK. All right. And then we can also provide a pick function, um, because we'll invoke pick. So virtual void pick, and we can just change this out whenever we want, and such. And we don't need to have pick up here. We can have an init function to just get that started. And I probably might do that in the init function. But let's just do that for now. That also means we need to get the getters and just the getters. VK physical device. Yeah. Device. And we also would like to have the device, the destructor here, and such. All right. And get this class set up here for our compilation unit. So, what do we need to implement? Just the pick function. The Vulkan device, and it's a void function. This pick functions, what I'm gonna just do is see the physical instance. This is enumerate. And then lazy wrap. We have to run, and since I put it virtual, that should be good. Um, lazy wrap. Create an algorithm to find the best key. We don't need to pick it since we already passed it in, but yes. And now we need to end it here. Alright, to initialize our device, we also would like to create a queues, I bet. And queue families. Suitable. Find queue families. Yes. Queue family indices. Yeah, I'm going to use a struct method that's on the Vulkan tutorial. It's pretty good for this type. There we go. And then we need a function to do all that, or no, we just gotcha. We can also we do need okay, get the optional. So what std optional here does is to set this as null or null-ish. It basically says this either has a value or does not have a value. And I believe it defaults to not have a value, if I remember correctly. So we can have like a function to make sure it's complete. This is completed. So if we can have um there we go. View family indices. Q family. And then that's pretty much it for that. Back to our physical device. When we initialize, we need to fill out our Q family. So we need to do a device get Q family property. And that's our function. We're gonna auto fill this because it's gonna be long. Q Q QF property. Um, and then I do have a function here, or a small algorithm. So int I equals 0. That's just int I equals 0 for const auto reference Q family or QF pro property and QF prop here. Um, if prop that count is less than 0, we do want to break out of this loop since we just don't have anything. If Q family or the property Q flags. So these are the flags of Q, or what framework it's in. So bitwise and it with the VK Q flags bits E graphics. So this is our crafts family. Indices. It's not gonna be indices, it's gonna be our Q family. Dot present family equals I. And I'm actually gonna keep it simple. Graphics and indices represent. All right. So our graphics family is there, and now we need our present. No, this is something else. So we actually need to get the physical device. That get surface support HR, our indices, and surface. So we do need our surface to get this started too. To get our surface, it's gonna be through GLFW. Um, but I think that's gonna say const vk HR reference surface, and then surface. And destructor, same as all of it. So yeah. So we initialize, and then Q physical voice, get service support, and then we can just say Q family that present, and this is actually graphics present equals I, and then if Q family that is complete, we take. All right, so we got our graphics queues and our queue families and our device kind of set up here. Comment here that queue family. Now we could. I'm gonna set up some of our queues since I have code written already. And then we create our device. It looks like so. Here we go. So let's create our. Let's see. Queue create info. Oh wait. Yeah. Oh, that's gonna be at the end here. Never mind. Our device create info, which is vk device create info. The first argument is gonna be vk device create info flags. Device create flags. One. Let's look at the device create info function here. So in our Vulkan.hpp, we can just paste that and create the device. Should be a struct, I think. Yes. It's a little bit hard to decipher this, um, but all you have to find is this constructor here. We already have the cat flags. We got the queue create info count. So we do need to set that up. Okay. So VK device queue rate info. VK device queue rate flags. Indice. Oh. Um. Okay, so we need to create our queues. We need to set up two queues here actually. Which is our present and graphics queue. So what I'm going to do here is create a std vector of whatever this device queue create info. That's pretty simple. Yep. And there will be two of these. So. PK device queue create flags. We want the queue family dot graphics dot value. We want one of these. And then the reference to view ARP. And do the same thing for our present. Alright, so we got a graphics and present queue create infos. And we can pass that on to our device create info. So we need to say queue create infos size, and then queue create info data, since we need a pointer there. Yes. That's pretty much it right there, unless we need something else. So device create device. So we got our pointer to our class. Create the device. Create. Let's see. Flags. Q count. The struct. Enabled layer count. And layer names, extensions, and features. All right. Again, somewhere. So, next up in our list, it looks like we already have the count and Q create infos. Now we need to do enabled layer counts or layers and layer names. So, if we have a static device extensions. Eh. Um, Duplicate tab so I can look at the header file. So now we need to get our device extensions and device layers. So we need a here, and we can do std vector and it's gonna be a const char pointer device layers vector const char pointer to device extensions. The layers is gonna be GK layer rows validation. And then for our device extensions, we just need a simple subtrain. And now we can pass this on. So for our queue, enable device features, we can do that later. And I believe it's our next one is, yeah, layer count and layer name. So device layer with an S size the device layers dot data device extensions because that would be the next one. Enable extension count, enable pointer to a pointer, extension names, and our features, which we can just do. Um, auto device feature. And we can just pass the reference to this. And that's pretty much it for the create info. We can try and catch here, but I'm just gonna do a simple, where's that? What does this do? what we can do is just do a simple device. Create device, create info, and that's how we create a device. We can try and catch to log stuff if it fails, but I don't really care. Graphics view device dot get view view family dot graphics dot value and 0 and present. Present graphics, we now need to store it, so we can store it up here. And then we can create getters. And check chat, nothing much. Okay, so now we got our graphics and present queue. We pretty much we're pretty much done with the device. We just need to get away or create our surface and call it good. Um, the only thing that's our context is heavily depends on is on GLFW. We would like to like abstract that out to be any window, honestly, but I'm lazy and I just want to get this done. So what I'm gonna do for the create surface function here, um, is to do a vk surface hr, create a raw surface for GLW to use. Um, instance, and then the window and the raw surface. And then assign back to our surface. So back in the context here, we should have a VK HR surface. And now we do need to include our Vulkan device on HTTP and then call Vulkan device. And then when we create devices, that I can find. Create devices. We just, when we create our devices, we can pass in our instance. So Vulkan device, and we can pass in our instance and our surface. Make sure that's correct. The service. Okay, chart. Yep. And then we initialize it. And then we need to clean up afterwards. So at the end here, we need to clean up our device. So we need to device um our device dot destroy, and that's pretty much it for device. Because the swap chain is on it's independent of itself. So that's good. Same thing with surface. When we destroy or when we get deallocated somehow, we want to destroy the surface. So device dot or instance destroy surface. Instance destroy service KHR. And there we go. I am actually gonna change the device to a pointer so we can control when it's deallocated. This is a personal choice, to be honest, but init resize destroy as this is because I want to control when it gets deleted. I can use like a shared pointer and it's virtually the same thing, but I'm just lazy. Um, let's build it. And fix any errors that comes up. There we go. All right, so this is a pointer. In the GLFW swap chain. I'm gonna ignore that. Device. Create window. Do I need to cast it? Window handle. Um, yes, I need to cast the window handle. Get rid of some of those errors. And it was a little. Okay, VK instance is not a pointer. It's a. I don't know why I did that. Ah, that's right. Um, cons of type VK device pointer. Okay, so I changed the wrong device here. All right. Can I convert VK instance type to VK instance? Yes. Um, this is gonna be a little bit tricky since we're using Vulkan HPP to GLFW, which is expecting the C version of the API. I wonder if we can just do that. Nope. Well, actually, that's better than what I had before. Mem initializer. Physical device. Instance surface. Alright. Q flags, physical device features, and present. So, physical device features. Maybe it's Q flag fix. And it's a period. Present Q. Q family. All right. So we do bin sandbox using Vulkan. We got a spring going. We do have an error. Um, Saying that each one of these must be unique. Um, the index must be unique. Okay. Um, we can just do a break, I guess, once we assign it. See if that works. Bad optional access. All right. Um, that means we're not assigning, so um, I did solve this back when I did the C version. So let me try to get the code for that. Okay, destroy. Nope, it would be under Vulkan device. All right. So eGraphics. Um, so bool has Q family as graphics. Well, we can actually change this around. Um, and Q family that graphics that has value. If it doesn't, we assign it. Otherwise, we continue. Um, Presentation support. Um, View family. That present as value. Let's see here. Sandbox. And still same thing. Unique. Okay. Um, That's preset. Hmm. Let's see here. Set up key families. Set up key families. Properties. Oh, here we go. So when we actually create the queues, graphics family key, create info. Index count 1. Oh, I guess. Yeah. Um, I guess the first one would be good, I guess. So, one, you, create info, data, and I'll just pick the first one here. So far, no errors. I can ignore that. And everything's all good. Effects extensions. With all of this, I can actually do something quite clever. I can just rep bk exp, and I can do ray trace. And then I should have a value called mock.txt. Or is it? Yeah, MV. And actually, right there, I'm using a GTX 1060, so apparently NVIDIA decided to give it ray tracing. I don't know. But yeah, that's pretty much everything. So let's go over what we did here. So close that, close that. Let's start back at the context here. We implemented the surface, again, surface for the window, or the window surface, I guess. We can actually abstract that and put that in the window handler class, but I'm not gonna do that right now. Um, and that's pretty much it. Well, create the instance and create the or create the surface and then create the devices. That's the main thing we changed in this context. But in the we did create our abstraction of our device. So back up here, device.hpp. We create a device. We just need an instance surface, and we can choose which we can override the choosing method basically. Um, and then we initialize it, and when we initialize it, we set up our queue properties. We find which queue, or which is our graphics queue and which is our present queue. We go through our queue priorities and create different queues for the graphics and presentation. Apparently, there's something wrong with creating two different. So we're just going to use the graphics queue as our present queue. And we generate our features and we create our device. The graphics queue, and then we create our graphics and present queue from our device. And that's pretty much it when it comes to the device. It's somewhat simple enough to, if you take some time to understand. But yeah, I'm gonna call it quits here, and I'll see you all next time.